Hi everyone! The goal of this video is to learn how to calculate the volume of a sphere. In order to do this, we are going to learn a special formula that works for all spheres. To learn this formula, we are going to do a demonstration in class comparing the volume of a sphere, you don't even have to draw this, I'm just having fun, to the volume of a cone. So this is what we're about to do right now. So this is what I need from you. I need you to pause the video, take out your earphones, and look up at the front of the room so I know you're ready. Okay, then I'm going to do a demonstration that tells you how a cone volume relates to a sphere. And then you'll continue to watch this video that'll go over the formula and how to use it. Okay, so pause this right now, no cheating. Okay, now that you've viewed the demonstration, I want you to explain in your own words why, well, we'll talk about why the formula makes sense, but like a little preview I want you to write here is I noticed that 2 cones is equal to 1 sphere. That's what we learned in the demonstration. Okay, using this idea, I can go ahead and derive the formula for volume of a sphere. So I know the volume formula for a cone is you would take the area of the base, so I guess I should say this is a cone. This is just helping us derive the formula. So area of the base times the height, and it has to divide by 3. Okay, because there are 3 cones that go into a cylinder. So this is a cylinder. Now that I divide by 3, it's a cone. Okay, now for a cone, the base is a circle. So to find the area of the base, it'd be pi r squared. So it's pi r squared times my height divided by 3. So that's how you find the volume of a cone. But what we said is that 2 cones equals 1 sphere. So all of that work there is for cones. Let's go ahead and figure out what the volume of a sphere is. So taking this, there are 2 cones in a sphere. So I have to take the 2 cones and add them together to get a sphere. So we're starting to get the formula right here. Okay, so this is 1 cone. I'm drawing lots of pictures today. Plus 1 cone equals a sphere. Now to get the final formula, I'm basically just going to simplify up the volume of a cone plus the volume of a cone. Okay, so I'm going to simplify this formula. And the first thing I'm going to simplify is anytime you have a height, that applies to a cone. But if you think about a sphere, right, you think about this, you don't have to draw this. But if you think about a sphere, the height is just the diameter. Okay, because the diameter is the same all the way across. So instead of calling it a height of a sphere, I'm going to say that's the diameter. Call that D. Okay, but I also know that the diameter, so the diameter here is just 2 times the size of my radius. So instead of calling it my diameter, I'm going to call it 2 radiuses. 2 radii? I don't know. Okay, so I'm going to substitute in 2 radii for the height, because that's the length of the height, it's just the diameter. So this now becomes pi r squared times 2r over 3, because my height is 2 of the radius, or my height is the diameter, plus pi r squared times 2r. Okay, I'm adding my 2 cones together. Now simplifying up the numerator here, I have pi times r squared times 2r. Okay, so really r squared is r times r. Okay, and this is 2 times r. So how many r's am I really multiplying here? Okay, the answer to that is 3. I have 3 r's. So pi, I'll just rewrite, but r times r is r cubed, because the 3 tells you that's how many times you're multiplying the r. Okay, now I also have a 2 here, so it's pi times r cubed times 2 over 3. Okay, plus this would simplify the same thing. So r squared times r, or the first, is r cubed. So this is pi r cubed times 2 over 3. Okay, to keep simplifying this up, I'm going to move the 2 to the front, because I find that people like to put the numbers at the beginning, just to make it look like, our normal form. So what this says is I have 2 pi r cubed divided by 3 plus 2 pi r cubes divided by 3. Okay, so really what I'm kind of saying is I have 2/3 of these plus 2/3 of those, because these are like terms. They're like terms because everything's the same. The 2 just tells you how many you have of those. Now, if I said I have 2 pi r cubes plus 2 pi r cubes, I would have 4 pi r cubes if I combine those fractions. When you add fractions, the denominator just stays the same. Okay, let me just show you what I'm talking about, just fraction rules off to the side here. So if I have, let's see, I have 2/3 plus 2/3. Okay, 2/3 plus 2/3 is really saying I have 2/3, and I add 2 more thirds. So how many thirds do I have? And the answer would be 4/3. Okay, now the only thing that's different between this problem is I have 2 pi r cubes, and I add 2 more pi r cubes. So how many pi r cubes do I have? I have 4. Okay, but really this is saying I have 2/3 pi r cubes plus 2 more thirds pi r cubes. So I have 4/3 pi r cubes. Okay, that's the same thing here, except you have the pi r cube, but just think of it as like if I had 2x plus 2x. Okay, so I have 2x over 3 plus 2x over 3, so I have 4x's divided by 3. Anyways, I said that in a lot of different ways. If you're uncomfortable with fractions, you can always come and talk to me about them outside of class. But all I did there was add the formula of my 2 cones, substitute the diameter in for the height, because the diameter is how tall the sphere is, and simplified it up. So I get the volume formula for a sphere is 4 pi r cubed over 3. If you have any questions, please write them down in the video. So we're going to do some problems now to find the volume of the Earth. So I know the diameter of the Earth is 7,917.5 miles, true story, and I want to find the volume. So I'm going to use my volume formula. So first thing you're going to do is just write that down. So volume of a sphere equals 4 pi r cubed over 3. Now I'm going to substitute in my information to calculate my volume. So if I want to know volume, I have to plug in my radius. Now I was only given the diameter is 7,917.5. So in order to find my radius, I have to take my diameter, 7,917.5, and divide it by 2, because a radius is half the diameter. So my radius, I'll just write that down over here. My radius is equal to 3,958.75. Okay, now that I know my radius, I can just plug it in here and solve for my volume. So that's 4 pi 3,958.75 cubed. Wow, this is going to be a huge number, and that's okay. Divided by 3, and that'll give me my volume. Okay, I'm going to tell you what I'm plugging in my calculator, but my calculator's off to the side, so just listen. What I'm going to do is I'm going to take 4, multiply that by my pi key, so 4 times pi. Then I'm going to multiply by 3,958.75, but this number needs to be cubed. So I'm going to put this in parentheses and then raise it to the 3rd power. I hit enter, I get a really, really big number, but then I'm going to divide it by 3. And in your calculator, you'll probably get something that says like 2.59874 something, and then there's like an e to the 11th. That is your calculator's way of writing scientific notation. So what that really means is, I'm going to round the decimal, but it's like 2.6, and when it says like e to the E11 right here, that's what you'll see. What that really means is it's 2.6 times 10 to the 11th. The reason it writes it in scientific notation is because it's such a long number. 10 to the 11th is 10 with 11 zeros. So instead of writing that all out, we can write it in scientific notation. It's really, really big, but I forgot one thing, and that we need units. And this is in miles, but volume is miles cubed. So it's a really, really big number. It's like 11 zeros long, so I'm not even going to write it. I'm just going to use scientific notation. That's what that means in your calculator. Okay, I'm going to let I'm going to let these 2 alone for you to try. So practice surface area, just a review, and find the volume of a hemisphere. Okay, the last one is one of those backwards problems. So given the volume, can you find the radius? Okay, so if I see volume of a sphere, I want to write down my volume of a sphere formula. First step to working backwards. So it's 4 pi r cubed, to the 3rd power, same thing, over 3. Now you want to plug in what you know, so you can solve for what you don't know. Now, the thing that makes this different than the original problem is, in the original problem, I can just plug in the radius, compute it, and get an answer. In this case, what I know is the volume, which is going to go on the other side of the equal sign. So I'm going to take that and plug it in here. 3,125. I don't know the radius. That's the variable I'm solving for. In order to do that, I need to get rid of everything that's bothering the radius. So in some order, which we'll talk about as we go through, I'm going to have to get rid of the 4 pi and the 3 and this cube, so then the radius would be alone. Okay, the first thing I see is that there's a fraction, so I want to undo that. Now, there's a bunch of different ways you can do this, but I want to talk about something that will help you with Algebra 2. If you divide by 3, what undoes division? The answer is multiplication. So if you divide by 3 and you multiply by 3, those cancel. It's kind of like if you have 3x equals 7, in order to undo multiplication, you would do division. This time you have division, you want to undo it, so you're going to multiply. Whatever you do to one side, you have to do the other. So those will cancel. And on the left side, you're going to have 3 times 3,125, which I plugged into my calculator, and I got this left side is 9,375. Okay, these canceled out because I divided by 3 and multiplied by 3. So all of it is 4 pi r cubed left. The next thing is you have this 4 pi times r cubed. You're going to have to get rid of the 4 pi. So if it's written next to it, that means it's multiplying. To undo multiplication, you're going to divide. So I'll divide by 4 pi. Okay. If I divide by 4 pi, division and multiplication undo each other, so nothing will be left here except the r cubed. Now this I have to plug in my calculator, so I'm just going to hit 9,375 divided by 4, and I'm going to do 4 times my pi key. And in your calculator, you should get 7,363.11 if I round. Okay, now this is a new step. If you want to get r alone, you have to undo everything that's bothering the r. So normally, you saw a lot of things like a squared plus b squared equals c squared. You'd have like c squared equals 25. You would take the square root of both sides to undo a square. Okay, this is a cube though. So a square root undoes a cube, and a cube root undoes a cube. The symbol for a cube root looks like a square root except a 3 on it. Whatever you do to one side, you have to do to the other. So a cube root undoes a cube, like a square undoes a square root, or a square root undoes a square. Okay, there's a button for this in your calculator. Depending on what kind of calculator you have, you might have to go to the math button if you have a graphing calculator. If I can show you in class if you're not sure where it is, but you'll take the cube root of 7,363.11. And then I get that the radius is 19.45, rounded of course, so maybe I should write approximately, and our units would be feet. Okay, I really like this problem because this is a preview of a lot of the algebra you'll be learning in Algebra 2. So you learn a lot about exponents, cube roots, square roots. It's also a good review of fractions from how we derive this. So as much as I want you to be able to calculate volume of spheres and work backwards, I also wanted to review algebra. So if you have any questions, please don't be afraid to ask.